In this video, we'll be looking at variance and standard deviation. We use S squared to denote for variance and only S to denote for standard deviation. So this is the formula for standard variance, 1 over n into observation minus the mean, all squared. So, but for standard deviation, S, it will now be the square root of variance, summation 1 over n summation into x minus x bar all squared. So this is the formula for standard deviation, especially for sample. But when it is in terms of population, when we have large number, that's in terms of frequency, variance becomes summation, you can say fx squared over summation f minus summation fx over summation f all squared. If you want to represent this in terms of this, you can say summation f into individual values minus the mean all squared over summation f. So this is in terms of this. The standard deviation S is square root of this. This, in most cases, is more convenient than this. That is because this is mean deviation. It takes a lot of carefulness to be able to evaluate this on your tables. So let's begin with this, the sample. If, for example, I have 17, 20, 22, 16, 25, and let's say find the variance and the standard deviation of this number. 17 plus 20 plus 22 plus 16 plus 25, which will give us 100. So which is summation x, summation of the individual observation over the number of observation, which is 100 over 5, which will give us 20. Having gotten 20, the variance now becomes the individual value minus the mean, all squared. So we sum all of them. So what we're going to have is 1 over n, or 1 over 5, our n is 5, multiplied by, the first number is 17 minus 20 all squared, plus 20 minus 20 all squared, plus 22 minus 20 all squared, plus 16 minus 20 all squared, plus the last value there is 25 minus 20 all squared, which if we evaluate all of them, we're going to get 54 over 5, which is going to give us 10.8. But for this variance, a more convenient way, since it is a sample size, and the sample size is 5, it is small, we can say n minus 1. We can say summation x minus x bar all squared over n minus 1. So if we're to use this formula, since this n is not up to 30, which means it is small, we're going to say 54 minus 5 divided by 5 minus 1, which is 54 divided by 4, which is going to give us 13.5. Here, if we are to look for the standard deviation S is now square root of the variance. The number we got here is square root of 10.8, not 10.5, because so 10.8. The square root of 10.8 is going to give us 3.286 to 3 decimal places. So if we're using this value, it's going to be square root of 13.5, which will give us 3.67 to 2 decimal places. So let's move to the next level. So using this as another example, you can see we have large numbers now. We can, and they are in terms of frequency. For us to find the variance and the standard deviation for this, it is grouped. So the first thing we do is to find the midpoint. That midpoint is our x. So we add these two together and divide by 2. So you can see 14 divided by 2, 7 here, 22 here, 37 here, 52 here, 67 here, and 82 here. The next thing, we can find our mean. Our mean is f times x. So this is number of males, f times x. This times this, we're going to get 5, 2, 5. This times this, we're going to get 1, 2, 9, 8. This times this, we're going to get 1702. So we're going to use the two formulas so that we can get the same answers, to prove that both of them we can get the same answer. If I add all of this, we get 260. So what I am going to have is, for the first formula, x squared variance is equal to summation fx squared over summation f minus summation fx over summation f all squared, so that I will have to find fx squared. So I can get it two ways, either by squaring x, multiply it with f, or fx, multiply it with x. Either way, I will get this. So 7 times 525 is going to give us 3675. So that's what we'll be doing. This times this will give us this, this times this. So by the time we compute all of that and sum all of them, we're going to get this. Therefore, this formula becomes summation fx squared, which is 390980, over summation f, which is 260, minus summation fx, which is this, 8330, over summation f, which is 260, all squared. And if we evaluate that, on this side we're going to get 1026.463. On this other side we're going to get 1503.769. So if we evaluate that, we're going to get 477.306 to 3 decimal places. So which is our variance. If we're now to look at, look out for the standard deviation, it becomes square root of 477.306, which will give us 21.847. So that's the standard deviation, and that's the variance. Let's solve with the other, that x squared is equal to summation f into x minus x bar all squared over summation f. This is the mean deviation. So we're going to create a table and say it is x minus x bar, and then create another table and call it x minus x bar squared, and then create another table and say f times x minus x bar squared, so we can get this. So x, which is this, minus x bar, we need to first of all find the mean. X bar is equal to summation fx over summation f, which is summation fx is this, 8330, over summation x, which is 260, and x bar is going to give us 32.04. We can use 32 approximately. So the next thing we're now going to do is x minus x bar. We'll write it down here, and the first one is going to give us about minus 25.04. And if we square that, we're going to get 627. And if we now multiply it with f, we're going to get about 47025. So that's how we do it. 22 minus the mean, we'll write it down, which will give us minus 10.04. If we square that, we're going to get about 100.80. We're using two decimal places, and if we multiply that with f, so that we can create that with f, which is 59, we're going to get about 5947.20. So once we're done with that, we sum them up to get this, which is this person, summation of it. So our variance now becomes summation of this, which is 124099.27 all over summation f, which is 260. And if we divide that, we're going to get 477.305. So therefore, this is our variance. Our standard deviation S is now square root of this variance, 477.305. So which is going to give us 21.847. So you see, with both formulas, we get the same answer.